Thank you for having me. Thank you for coming here. I'm very, very honored to be here to present what we have been doing in Norway, in the project in Brevik. But before I start to present that, I must say that the presentation you gave earlier from the TP-Link, I must congratulate you to a very, very nice project. To me, it seems that you have more or less everything in place to take the next step, to take the decision, and to move. Because from what I saw on the plan and the hurdles and the things that needs to be solved, more or less everything was in there, I think. So you have a very, very good starting point for taking the next step. And just to give you an idea who I am, I haven't met many of you before, but I've been a very long time in the business. Today I'm the commercial director for Northern Europe, which means my responsibility to sell basically the products that we now are producing without CO2, which is a very, very good work. I've been 30 years in the company, mainly on the technical side. I've been the plant manager, I've been technical, let's say, cluster manager. I've been in the R&D, and right now I'm in the commercial. And especially when I was the cluster manager, I was responsible for the cement plants. We had 6 plants at that time in Northern Europe. And that was the time when we took the decision to move with the Brevik project and all the technical things. And during that time, I was responsible for the plant. Heidelberg Materials, for those of you who don't know us, we are a very huge company within the building materials. More than 50,000 people employed over the world. We are 3,000 locations worldwide. We are both in cement, aggregates, ready-mix, also actually some precast, it's not mentioned here. We have around 100 cement plants in the world. I heard this figure also before, coming to the targets. Heidelberg Materials, I'm very glad to say that, because in these times when things are moving in terms of environmental ambitions in the world, Heidelberg is still very ambitious and just also launched the 2030 ambitions. Taking then, especially if we look at the cement, they have the ambition to take the cement from, it was mentioned before, this emissions per ton of cement. We were at 750 kilos per ton in 1990, and the ambition is to take it to 400 kilos per ton by 2030 already. So that's only 4 years away. So it's not so long to go. We have already taken some steps, of course. We were at 2022 is the latest updated figure I have on this slide. I'm sorry for that. We are at 551, and the levers are, of course, to work with the product, to use as less clinker as possible, to work with the process, to push the alternative fuels. But the last step that was also mentioned before is, of course, to implement the CCS or CCU. It's important, I think, to say that even with the implementation of CCS and CCU, the ambition to still optimize the product and to push for the fuels will not disappear. In many parts of the world, these are the most simple steps and the most cost economical steps to take. But in order to get all the way down to zero, eventually, the CCS has to be implemented, as was also explained before. The target for the CCS is to collect somewhere around 10 million tons by 2030. So time is running. Again, if we just focus on the cement, there's 400 kilos per CO2 per ton. This is worldwide in all our plants, which means that in some part of the world we have to go much lower than that. The 10 million tons is the cumulative CO2 that we want to catch, and basically this will mean that we follow the carbon footprint reduction in line with the overall target of the 1.5 degree target. To do this on the CCS, and I said that I think Heidelberg is pushing this very, very hard. We have 2 projects right now. I will present the Brevik project more in detail. We have 2 projects up and running. So that's Brevik with 400,000 tons CO2 per year, and we have a smaller one in Langfurt, Germany, of 70,000 tons. Then we have taken a final investment decision just this last year to go with the investment in Padeswood, where we aim to collect 800,000, so it's twice the size of Brevik. And the next in line, and that is very close to the final investment decision, it's the larger plant in Edmonton, then again going up in size to 1.1 million ton. The catching, I will come back to that. But then we have several projects under quite in the development phase. Some of them are quite far ahead, like the one I have to push that all the time. You know, I'm from Sweden, so the Slite, and that will be the biggest one. That's 1.8 million tons. And you have several other projects as well. And they are, the reason why they are not moving, I say, to final investment is very often from a financing point of view, that you have to come to an agreement with the government and also with the EU in this case, if we are located there, to find the right investment scheme to make these projects move forward. And then we have some pilots as well running with different types of technologies. We have the Leilac 2, probably some of you have heard it. It's a separate calcining project we have been running for quite some time. And then we have made two quite big projects on oxyfuel, both the calciner part and the full line that we do in Magerstedt in Germany. But this is more on the development stage, I would say. But from a technology point of view, things are moving. But most of these projects are so far based on the amine technology, which is the one I think that is ready for deployment on large scale right now. It was mentioned, this Longship project. This was a Norwegian, or is a Norwegian, state project, I would say. And I think it goes very well in line with what you were presenting with this Carbon Link project, that this was a project launched by the state to take a full look, let's say, at the value chain of CO2, all the way from the emitters, that's us, to storage and transport, and all the way down to the storage. Initially in the project, there were the storage part, and that was handled by mainly by the oil side. Equinor is a big Norwegian oil company who came in, and then they formed this Northern Light concept, and they are responsible for the storage and transport of the CO2. And then we have two emitters in the project. That was Heidelberg Materials with our plant in Brevik, and Celsio, and that's a power plant, power to waste to power plant in Oslo. They were there in the project initially, but halfway through the project they fell out because they couldn't get the financing. But now they are actually back in again, so they will be up and running in 1 year or two. We are already up and running. I will show you that. Okay. So I will focus on the Brevik project just to show you how a project at an emitter side can look. This was the first one in the world. So we have always called it a pilot, even though it's 400,000 tons per year. But still, it is actually a pilot because it's the first one up and running. And the target for this plant is to capture 400,000 tons. It's 50% of what we emit in the plant. The plant emits around 800,000 per year, but we chose 400,000 for two reasons. One is that it is a pilot, so it's the first one, so we wanted to restrict a little bit the risks, even though it's a huge risk already from the start to build this size. The other one is that this amine process that we build needs a lot of energy. And the internal energy available in a cement plant in terms of waste heat and so on, and other plants are normally doing, for example, electricity, you can use it for drying and so on. And the energy available is more or less enough to also power the capture of CO2. If you want to go above that number, you have to add a lot of extra energy, normally in terms of electricity. And these are huge amounts of electricity, both costly and sometimes not available. So it was a very good level to start at, I would say. Okay, I had a discussion on what to present, and one thing that the message that I should get through here is that it takes time to get these projects materialized. Just to show you here, we have actually used this from the very beginning of the project, and so we started to add each block when we went through the project. We added one block after another, and I asked the project manager at what time, shouldn't we change the guy who is running up these blocks to be a little bit older and a little bit slower, because we felt it was going a very long time. But we have kept him as a very athletic young man running up these stairs. Anyway, we started in 2005 with we call it a full desk study. We got actually some funding from ECRA at that time. We made a study where the industry, let's say, were in terms of what types of technologies are available and how could a project like this look and so on. And we used that study to start the pre-engineering, and that eventually went into, we had a big seminar in Oslo around about 2013, where we then formed something we call the Technical Center Brevik, where we went together, and us, Yara, some other industries, to look at 4 different types of technologies and to make a very much more deep study in which of these technologies are ready to be implemented. So, and in that study we were running then, the main one was then started to run a test unit for carbon capture. So we ran it for 7,500 hours together with Aker, who was later then the supplier of the system to the plant. And after this test, we started to see that the amine was the one that was ready. We also tested membrane. We tested calcium looping at a very small scale. But at that time, the amine was the one that was ready. That's also a little bit difficult in these types of projects when you have 5 to 10 years of implementation. Technology is moving very quickly. And how can you be sure you're actually investing in the right technology? Because it's like when you buy a TV in an electronic store. When you move out of the store, you know that there's a new TV, half the price, double the, you know. So it's not moving that fast. So we see that now. Even though there is a lot of development ongoing, we still see that the amine that we now have is very, very efficient and definitely a technology that we still actually would go for if we were to choose today as well. So we went through these steps, the concept study, and then in 2018-19, it started to move. We launched then the FEED study, made a huge number of reports, and finally then had a decision by the government to move in this Longship project in the date is, I don't have my glasses here, so I don't see here, in the September 2020. And it was good time to get, of course, but the timing was maybe not perfect because, as you know, in 2020 we had the COVID running, so not perfect to start the project with a huge number of people coming into the site. Very difficult then to move. And the second was when the project was up and running 1 year later, then Ukraine, you had the Ukraine, terrible things going on there, which affected us a lot as well, because supply of steel, for example, to these types of projects is a large part coming from Ukraine. And also electricity components and so on were definitely hurted by that. So the project was suffering a little bit from that. But anyway, pushed through. And then in 2024, we had then had mechanical completion. And then during last year, we could finally start the project. All along this line, the interest of the project has been, of course, huge. We have had visitors. I think many of you have been there, visited both maybe the plant and also the Northern Lights facilities in the garden. And then we have had, of course, the authorities and government. They are definitely crucial in this project. They have, first of all, funded to a very, very large extent all the things that we have done. All the studies, the FEED studies and so on, they funded up to 90%. And when we come to which is extremely high, I know that. And when we come to the technical project, they have been in the level of 75% funding, which is, of course, also very, very good for a project like this. And as I said, you know, the interest of the project has been huge. So no matter what kind of weather it was, we have the German vice chancellor there. It's our CEO standing there also in the background, not very happy with the weather. I said, we cannot control the weather, sorry for that, but you have to run. But anyway, the media was there. Everyone is looking. But it also shows a little bit some of the difficulties we have also during erection, because these are the conditions that we have to work in when erecting the plant, which is not always easy in Norway, especially wintertime. Okay, the plant, it's located in the southwest of Norway. It's very cramped into the mountains, not so much surface. And for those of you who are, seen a cement plant before, maybe you wonder where the quarry is. And the main quarry here is actually under the plant. It's in a mine, which is extremely rare. But this plant has a mine all the way going also out under the fjord. Okay, some short facts on the project. It's of course a huge project. We have 1.4 million hours of working time. There's a picture with some of the construction people at site at one point in the final end of the product. You have 18,000 meters of piping and so on, 2,500 valves. It's really not a cement plant for us. I've been, from the mechanical side in cement for 30 years. This is more oil and gas. And for us, it's very new. That's also something to think about when you start to construct this, that the cement guys and girls are not completely, ready, what kind of standards and so on. So this is something to think about. Very good record when it comes to health and safety. We're very happy for that. No major injuries and only 4 LTIs over the complete project, which I think is a huge achievement. And again, the first full-scale plant up and running now, so we are happy for that. This is another view of the plant, just to show you what type of achievement this is. You have the quarry, the rock coming up actually from the quarry then to the storage, up on the shield, and then you have the cement plant going out. And all the cement that we produce goes out through ships. And now also the CO2, of course, will take that road. And everything in color here is what needed to be added when we made the CCS. If you just look at the CCS itself, it looks like this. I cannot go into the details because that would take too long, but for anyone who's interested, we are more than happy to share everything, of course, around this facility. And then the storage and transport is, of course, a big part of this. In our harbor, we have a storage facility that can take 4 days of production only. And then we have to have a ship then waiting at the harbor. So basically, 1 or 2 times per week, we will have a ship leaving with CO2. So it's very new now for this. In the past, we just delivered cement. Now we deliver cement and CO2. Almost, 50% of the volume is now CO2. So it's a huge volume added to the total volume that we actually transport out of the harbor. It's something to think about. Some pictures from the plant when it's ready with the new stack and the whole. Most of that is waste heat recovery to drive the amine process, which is in the heart, where you actually capture the CO2 at one temperature and it releases as another, and then you do that in a cycle, and you need a lot of heat to drive that. So we have a lot of waste heat exchangers and so on in the plant, and compressors and fans and valves. And here is when we started the plant, and we had a big celebration in June last year. Everyone was there, and down to the right, it's the Crown Prince of Norway. So we had a lot of distinguished visitors to have a look at the first operation of the plant. And here again, the storage tanks in Brevik in real life. This is actually an animation. It doesn't work in the PDF format I sent you, so I think we will skip. But you will get you can see how it works basically. We have the capture. We then load all the CO2 on the ship. We take it to a Northern Lights facility, which is on the little bit higher up in Norway on the coast, where we then offload the ship. They treat the CO2 again. They bring it up to a higher pressure. And then from that facility, they then pump it in a pipeline down into the seabed, 2.6 kilometers below sea level, so very deep. And they can then connect others. We are the first ones. The system is now up and running. Now they are waiting for this waste plant in Oslo, and they are also negotiating with others. And it's built in this way that they have now one hole. I saw that in your plan as well, that when that is full or when the capacity is reached, you only have a certain capacity for each hole. They can just add another one and another one, so they can go up in capacity in the years to come. This is the plant in Øygarden. All right, since I'm in commercial, I need to talk about the product. I have to take the opportunity to sell a little bit here. No, but I think it's very important. I think this is also something that is interesting to understand what will happen on the market when this product comes to the market. This is what we are now offering the local market in the Nordics. So that is Sweden, Norway. We can deliver to Denmark, Iceland maybe, but especially Sweden, Norway. Our main cement, the normal cement, if we talk about EPDs, for those of you who are familiar with that, this is the declaration of CO2 basically per ton of cement. We are already quite low actually in our product. It's 451 because the plant is an efficient plant. We have very high amount of alternative fuels and the clinker share is on medium level, I would say. We have fly ash as an SCM. So 451, that's the start. And if we take then the 50% reduction, that will bring a product to 230 in EPD. And that's lower than what you possibly can achieve with other types of cements. Even if you have huge amounts of slag and these kind of SCMs, you will not reach that number. So it's already a very good start. If you want to go lower than that, you can then go for what we call the Evo Zero product. And then you add additional then 184 kilos of CO2. And we take that from the carbon that we have. And then you have a product with 46 kilos per ton of. So very, very close to zero. We are not allowed to say a zero cement. It's very important from a law. The lawyer said you cannot say that because it's not zero. So we have to say near zero. But it is as near zero as you can come. And the reason we cannot take it to zero because we are not allowed to reduce the CO2 from other activities than our cement plant for transport and these kind of things. We cannot just remove that by taking from what we have captured. It's a little bit technical. But these two products now we are offering the market. And for you, this is also a big part that has been necessary to develop in order to create these products. And that's something to think about when you construct a plant. If you do it here, for example, and you have one plant with 100% CCS working and the other 5 not, then what will you do with the market? If you have a customer very near to that plant with a CCS, and they are not interested in buying your CCS product, do you have to take it from another plant, or how do you do that? So you don't. We are giving the customers now the opportunity to buy still the old cement, we call it the gray cement, or they can buy the carbon reduced and halfway, or they can buy the whole way reduced, the Evo Zero. And this is the way we do it. We take the cement out of the plant and the CO2 that goes to the storage. We will take certificates from that and we will put that in a carbon bank. So every time we have a ton going down in the sea, we get 1 ton into the carbon bank. And then we use that carbon bank whenever we sell a product that we want to have a reduced CO2 footprint. We take some of the CO2 from the carbon bank. And that's a huge system. It's verified from third party. It's DNV doing that for us. And it's also a pilot, I would say. It's new. But we are learning a lot, and also to get the customers to agree to this and say that this is the right way to go. It's also a discussion we have, because the word mass balancing is coming into to play and those kind of things. And so it's steps to take. But from where we are when we have one CCS to where we should be in 2045 when we have only CCS, we have to do these kind of things to make it work. And eventually, we will find a system where you sell all the cement near zero. And I will show you this one as the last slide. What you actually can do with this product in construction is amazing, I would say. To the left, you can see the CO2 impact in construction. You have the reference is 193 CO2 per square meter build or something like that. You can reduce that by 40% roughly by using improved concrete with slag and these kind of things. And if you then start to move with the products, the Evo Build and Evo Zero, you can bring it down to 73, 90, or even very, very near zero. And if you go then to the right, you can see the impact of the buildings, of the concrete in a residential building. It's 42%. You have 36, a little bit less in the office. You have smaller walls, I guess, in office. In the bridge construction and road construction, you're up to 55%. So by implementing this evoZero product into this project, you can reduce the CO2 footprint for that type of construction with more than 50%. It's a very, very effective tool to reduce your CO2 footprint overall. And you can do it on massive scale all of a sudden. It's not that you are changing your vehicles to electrical driven and you take away a few kilos. Here we are talking about percentage of what's actually emitted in a country. So it's a very, very strong tool. And it's an interesting discussion we have now with the customers, whether this is the cost-efficient way to reduce or not. I am convinced, of course, but I'm subjective, that it is a very cost-efficient way to reduce the CO2. But these are the things that I think that we have to work with now, from now on, together with our customers, to show that this is actually the way to go. Because if the customers don't buy the product, then it will be very difficult to build the systems and the plant eventually. And the opposite, if the customers throw themselves at this, we are sold out, everyone wants it, you will build your next facility here very, very quickly, because there is money to be made. Okay. So 20 years later, we are there. Hopefully, you can do it much faster, I'm sure. Thank you.